Imagine a currency so perfectly constructed that forgery becomes a mathematical impossibility. This is the hexapuss, a theoretical banknote designed to be uncopyable at its very core. Base-level currency security relies on dizzying, microscopic line art. These overlapping loops and whorls, seen here surrounding a 1,000-denomination bill, are far too complex to replicate. This style of decoration, called a guilloche pattern, is generated by algorithms to achieve perfect mechanical precision. This first line of defense works by translating abstract math into an impenetrable two-dimensional physical maze. To engrave these patterns onto mint plates, 19th-century engineers used a geometric lathe, a machine built specifically to generate continuous interwoven geometry. These lathes operate on the same gear-driven principle as a spirograph toy. A fixed outer circle guides a smaller rolling wheel, tracing an unbreakable path. These curves are known as hypotrochoids. They are formed by parametric equations, where every point on the rolling circle is accounted for by a precise mathematical value. However, high-resolution digital scanners can now capture these flat designs with perfect clarity. If a pattern exists on a 2D surface, a computer can reverse engineer and copy the lines. To stay ahead of modern forgery, the math behind the guilloche must evolve beyond the flat page and expand into physical architecture. The hexapuss note solves the 2D vulnerability by moving the geometry into a layered 3D grid. This mimics the tactile depth of real-world intaglio printing, but on a structural level. Glowing nodes of math map the z-axis, physically binding the patterns across multiple holographic planes. In this configuration, the interlacing lines extend through the layers to act as structural support pillars, holding the banknote's multidimensional architecture together. By weaving the math into the physical depth of the object, the currency becomes a structural lattice that is impossible to replicate with a simple surface scan. This structural grid follows a rigid sequence of divisions, building its complex geometry around the variables 3 and 6. This specific numerical logic is borrowed from quantum chromodynamics, the branch of physics that studies the strong interaction. At the subatomic level, force carriers called gluons interlace to lock particles together. The hexapuss grid uses this same interlacing logic to secure its physical form. This diagram reveals why the numbers 3 and 6 are so critical. Quarks operate with 3 color charges and exist in 6 distinct flavors, forming the foundational parameters for the strong force. The QCD Lagrangian formula defines these interactions. Because this particle binding is governed by the absolute rules of the SU3 symmetry group, it provides a perfect mathematical code for the note's security. By using the literal mechanics of particle physics as a blueprint, the hexapuss note ensures its structural integrity is as unbreakable as the atom itself. To reach the absolute limit of security, the hexapuss note scales this quantum grid into the 6th dimension. A 6-dimensional space provides 6 degrees of freedom, allowing for the construction of 6 polytopes. These complex, unforgeable geometries cannot be fully expressed in our lower dimensional reality. At the heart of the note sits a central guilloche pattern that converges into a feline eye, the puss giving the currency its name. In 6 dimensions, extreme geometric complexity warps the surrounding space. The dense lines in this central eye collapse the geometry, forming a localized singularity. This singularity functions as a geometric dateway, theoretically folding our 3-dimensional dimension into a secure 6D mathematical space. From a simple banknote to a cosmic gateway, the wriggling lines of the guilloche demonstrate that math is a universal language, capable of binding subatomic particles and mapping the 6th dimension.